Okay, here's problem number 1 from exercise number 8. It has to find all the values C that satisfy the conclusion of the mean value theorem for the function blah 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 on the interval from -1 to +1. All right, I'm going to not just do this problem, but I want to do a little bit of review of the mean value theorem. I want you to recall that the mean value theorem says that if f is continuous on some closed interval from a to b, and if the function f is differentiable on the open interval from a to b, then there exists a c on open AB such that f prime of c is equal to f of b minus f of a over b minus a, or that the average slope is equal to the instantaneous slope. So let's just ask this question. Is this function 3x squared minus or plus 2x plus 5, is it continuous on the interval from -1 to 1? I say that's true. It's a parabola, it's continuous everywhere. Is this function differentiable on open a to b? Yes. The polynomials are differentiable everywhere. All right, so therefore, there must exist a c such that f prime of c, well, I better find out what f prime is. F prime of x is equal to 6x plus 2. Yes? All right. I'll need to find what f of b is. Well, b is 1, so f of b is f of 1, which is equal to 3 plus 2 plus 5. That's equal to 10. I'll need to know what f of -1 is. That's my f of a. And that's going to be 3 minus 2 plus 5, which is 6. So now I can start plugging in what I know. F of b is 10. F of a is 6. This is 1, and that's -1. And what is f prime of c? It is 6c plus 2. So can we find a value c that satisfies this equation? So 10 minus 6 is 4. 4 divided by 2 is 2. So 6c plus 2. Let's subtract 2 from both sides. I get 6c is equal to 0. So c must be 0. Is c indeed on the interval from -1 to +1?
Yes.
Yep. So this is the value c that satisfies the mean value theorem.